Good morning everyone. In our lesson heat, we learnt about the thermal energy and its effects. We also learned how the heat get transferred by three methods. Heat capacity, then specific heat capacity, Q by M into delta T joules per kilogram Kelvin. An higher order thinking question. Why does the bottom of a lake not freeze in severe winter though the surface is all frozen? The ice that formed on the surface of the water acts as an insulator. So it does not allow the heat to be withdrawn from the water. So the bottom of the lake does not freeze in severe winter though the ice formed on the top of the lake. Solutions for the previous class assignment questions. You can note down it in your notebook.
Today's class we are going to see about applications of heat. Heat is also known as thermal energy, is an important source for our life. It is used in many fields and equipments. Today we are going to see three main applications of heat. Number one, calorimeter. Second one, thermostat. Third one, thermos flask. First one, calorimeter. You can see the apparatus here. It is a device used to measure the amount of heat gained or lost by a substance. It consists of a vessel. See the vessel here? This vessel is made up of metal like aluminium or copper. Why aluminium and copper are used here? Because those metals are good conductor of heat. That's why the vessel is made of metals like aluminium or copper. And this metallic vessel is kept in a jacket, a wooden jacket. See, this is an insulating jacket. Why this insulating jacket is here? It is used to prevent the heat loss to the environment. There are two holes in the wooden box. Through one hole, a stirrer is inserted to mix the water. Through the second hole, a thermometer is fixed, which is used to measure the heat absorbed.
The vessel is filled with liquid which is heated by passing current through the heating element. Using this device, we can measure the heat capacity of the given liquid or solid in the container. Our second application is thermostat. A thermostat is a device which maintains the temperature of a place or an object constant. The word thermostat is derived from two Greek words, thermo meaning heat, static meaning staying the same. Thermostats are used in any device or system that gets heated or cools down to a preset temperature. It turns an appliance or a circuit on to a preset temperature, and it turns the appliances or a circuit off when a particular temperature is reached and slow down the process. Thus, it helps to maintain the preset temperature in the appliances. Thermostats are used in devices like building heaters, air conditioners, ordinary water heaters, and kitchen appliances like ovens and refrigerators. Next one is thermoflask. Thermoflask has double walls which are evacuated. It is silvered on the inside. The vacuum between the two walls prevents heat being transferred from inside to the outside by conduction as well as convection. As the space between the two walls are evacuated, there is a little air between the walls only. This almost avoids the transfer of heat from inner wall to outer wall and vice versa. The glass silvered surfaces reflect the radiation heat back to the liquid into the bottle. Conduction can only occur at the points where the two walls meet, that is, at the bottom of the flask, foam plastic support, or at the top of the bottle, the plastic cap. Now you can watch this video to know how the principle is applied in the formation of calorimeter.
Calorimeter. The exchange of heat depends on three factors. First, mass of the substance, or M. Second, specific heat of the substance, or S. Third, difference in the temperature of the substances, or T. We use calorimeter to find the specific heat of the substance. A calorimeter is a cylindrical copper container kept inside a wooden box. The space between the container and the wooden box is filled with cork, sawdust, glass, or wool. That is basically a substance which is a non-conductor. The wooden container has a lid inserted with a stirrer, and it also has a thermometer. A measured mass of water is taken in the calorimeter and its temperature is noted T1. The substance whose specific heat is to be found is heated up to temperature T2 and then transferred to the calorimeter. The water in the calorimeter is stirred and the final temperature of the mixture T3 is found. With the help of mathematical formula, heat lost is equal to heat gained, we can calculate the specific heat of the substance.
Another question for you to think. Which one of the following statements about thermal conductivity is the correct one? Give the reason. Answer: steel, water, wood. Because steel has higher thermal conductivity than water and wood. So in this class we have seen three main applications of heat. Now observe the following answers. Write it in your notebook with the neat labeled diagram. Thank you.